guys, in this video we are going to be solving equation on first order variable separable differential equations. So the equation reads, solve the differential equation dy by dx equal to xy minus x, given that when x is equal to 0, y is equal to 2. So the first thing is that since we can identify that it is a first order variable separable differential equation, then we just need to separate the variables and integrate. Separating the variables, we begin by factorizing x from the right hand side of the equation. We are going to get dy by dx to be x into y minus 1. To separate the variables, everything in terms of y on one side, everything in terms of x on the other side. So we divide both sides by y minus 1 and we multiply both sides by dx. We are going to get dy by y minus 1 to be equal to x dx. Doing that, we have separated the variables, hence we can integrate. So we integrate both sides. We integrate the left hand side and we integrate the right hand side. Integrating the left hand side, we just get the limit of the absolute value of y minus 1. Integrating the right hand side, we just get x squared divided by 2, then plus our constant of integration. Alright, so we now need to fit in our initial conditions. When y is equal to 2, we have x is equal to 0. So we fit y to be equal to 2 here and we fit x to be equal to 0 here, and you look for the value of k. Now the ln of 2 minus 1 is the ln of 1, and the 0 here is just 0, so k is equal to the ln of 1, which is 0. So we fitting back k into our equation here, we get the ln of the absolute value of y minus 1 to be x squared divided by 2 plus 0. So the ln of y minus 1 is equal to x squared divided by 2. We can take exponential on both sides. We get y minus 1 to be equal to e raised to the power x squared divided by 2. We now add 1 on both sides, so we get the function y to be equal to e raised to the power x squared divided by 2 plus 1. Alright, thanks for watching and see you in the next video.